Hello, this is Audrine and Lucas, and this is the screencast for Assignment 1 RSA implementation. I'll be showing you the application and the run through, and then Lucas will show you the code behind the application. So this is already run, and then this is the menu: 1 to enter the message, 2 to encode, 3 to decode, and 4 to change the bit length for the prime number, which creates the world. And to enter the message, has to be perfect. Okay, so this is the message, and then if I go and decode it now, it will show me an error message that I have to encode the message first. So I will go and encode the message, and here is the prime number created from the bit length, which is set as 512 at the moment as default. And then this is the public key, and then the private key generated from the public key, and then this is the message, the byte of the message, the numbers, and then this is the encoded message. And then after that, this is the decoded message, and it shows me the message that I typed in. Yep, and then here I can change the bit length to maybe 100, or I will show you 8 that is really small, and it would show you the wrong decoded message. So I will encode it again, and then you can see that it's really small now, and the decoded message, it would be error because the message is larger than the mode, the world. So this will show you the wrong encoded and decoded message. So yep, and Lucas would show you everything behind the code that we written in here. Okay.
So this is Lucas here now. I took it from Audrine, and I'm going to explain the code behind the application. So I'm starting with the main app, and in the main app is just a simple main app which starts and run the while loop, which runs our menu. So if I go into the menu functions, this is our menu with the code. We created all the variables we needed on the top. So we have a message, input, encoded message, decoded message, prime numbers we need, public key and private key. So I start with the message, and if I go to my function, if I press 1, it just says that I have to enter some message for encoding, as you could see when Audrine was showing you the application running. Next, if I press 2, is to encode the message. So if the message is null, of course it shows you the error, and then else it's gonna encode it. So I'm going to generate the random prime numbers, then I print them out, then I generate my public key, print the key that I can see what is happening, and then I print the message and print the message as it is when I convert it into binary. So now if I go into my generation of my public key, here is the function, which is the generation of the public key. I show you first the prime numbers, how it looks here. So the prime numbers is just 2 prime numbers that I will need to generate my mod and a phi mod, and the bit length is how big are the prime numbers generated. I'm going to generate 2 prime numbers. We're working with the big integers, so all the numbers that we are using as a big integers. Now we have a bit length. This is the bit length we can adjust. So if you want numbers which are smaller, we just make the bit length smaller. Then we are going to check that they're not equal in here, and we check that they're both prime. This is just another function to make sure that the both numbers are prime. And if they're equals, it won't work. So we just run this function again, so it's a recursive function. Then I'm going to generate my public key. So I generate the prime numbers. As you can see, prime number 1, prime number 2. I know now they're not the same. I multiply them together. Then I generate my mod that I'm going to work in. So I subtract 1. This is all with a big integer, so that's why it looks like this. So I subtract 1, multiply it by another prime number from which one I subtract 1 again. Then I'm going to generate another prime number with the bit length, with the same bit length, which is my public key. And I'm just taking the first of the 2 prime numbers that I generated because I just need one. After I generated my public key, I go back into menu. So I encoded the message. Now I want to decode the message, and I will need to generate my private key. So I go into the function when I generate in the private key, and I'm passing the public key into the function. I'm going to get my mod and my phi mod into my public key. So this is the function that I'm getting greatest common divisor. So I passed there a phi mod and my key. So the greatest common divisor is 1. This is another recursive function. The greatest common divisor is 1, and it returns me an array, as you can see here, which will return the greatest common divisor and how many of the 1 and how many of the second of the 2 prime numbers it's going to be in 1. So if my number can happen that it will be minus, so it will be, for example, minus 20 times the key and plus 10 times of a mod. And because I want the key to be a sign plus number, I'm going to add to it the same amount, so I just flip the signs. So this will be plus some number plus like 50 of my key and minus, for example, 10 of my phi mod. So I will have the plus number I need, and it also prints out into the screen that I know that is happening. Then I have my key generated, which is just the inverse of my public key in the phi mod. And after I have my private key generated, I go back into my functions. So now I can encode and decode message, as you can see. Please, I just check it here. So encode and decode. So encode is 2, that I generated everything I need, and I have a small function in here that is called encode message. So I go into it. So what I'm going to take my message as in a form of bytes. So I'm getting the bytes of my message. Then I pass it into my encode message function, and I pass my public key, and then I going to raise my message into a power. This is another function of a big integer mod power of my key in this mod. After I encoded message, it was printed on the screen, as you could see. I'm going to decode the message, which is another function just right under. I'm going to take my message in a bit length, in a bytes, and I'm going to get my private key, and I'm going to use again the mod power of the big integer function, which I'm going to get my message to the power of my private key in the mod of my world. After I done that, it basically just reverses the process and I get my message back. So that was all that I wanted to talk from behind the code. Thank you very much.